In this video, we will be solving trigonometric equations. The problems that I have in this video are based on a particular worksheet that I answered a few days back. I have to say that I have the liability to say that it's not my worksheet, so I just borrowed it for the purpose of teaching you how to solve trigonometric equations, the topic on that worksheet. So particularly for this video, the problems will be based on a specific standard. Our answers will be only limited from, the answers will only be acceptable from the range of 0 to 360, as you can see here. The answer could be solution 0, or it could be 360, or any number in between the particular specification. So yeah, let's start. Please do not expect any specific definition on this. We will be we will be basing this video on primarily on solving. So let's proceed with number 1. Sine raised to 2x is equal to 2 sine x. The first step that we could do here in this particular situation, we have to place all the terms at the left side of the equation. So we'll have something like this. And we're going to borrow some methods that we usually do at when it comes to solving quadratic equations. So particularly factoring or FOIL method, whatever suits best in the situation. So in this situation, we can factor, not FOIL. So we can separate the equation into 2 equations. So we have something like this, and x is equal to arc sine of 0. At the other side, we have to transpose negative 2 to the other side. It will become positive 2. And likewise, we will be transforming sine x equal to 2. We'll rewrite it as x is equal to the arc sine of 2. Now, I hope you have your calculators with you, your scientific calculators. You'll have to place this value in the calculator, and the answer would be 0. At the other side, arc sine of 2 would be math error. When when the calculator says that this a particular solution is a math error, that means x is undefined. Or in other words, there is no solution at all. So for this part, this is considered a solution since it falls within the specification that the solutions could only be from 0 to 360, as you can see here. Now, there is a specific rule when it comes to sine, particularly for sine. Once we get the solution, whether it is a solution or not, we will be using that x in finding the other solution. The maximum would be 3. So if the first solution is considered a solution, our first x, by the way, so x sub 1 actually, if it's considered a solution, then we'll be having 2 solutions. Also, provided that 360, the x would only be 0, since 360 plus x is 360. 360 is the maximum quantity that is accepted as a solution, provided this specification. Now, in that sense, let's take the formula to action. So 180 minus x is, in other words, 180 minus 0. X is equal to 180. That is our second solution. Now, for our third solution, let's see if 360 plus x, or in other words 360 plus 0, is hopefully it falls within the range, within the specification. So technically yes, it does. Don't forget to place the degree symbol. So yes, that's how we solve. And as you can see here at the right, this is basically the graph that represents, it reflects how true the given solutions are. So yeah, that's it. Let's move to number 2. For number 2, 4 sine raised to 2x minus 3 is equal to 0. We won't be using, or we won't be borrowing the specific processes on how we solve quadratic equations. In this particular problem, we have a different technique. We move 3 to the other side. Then we divide both sides by 4 to make sine raised to 2x all alone. We end up with something like this, and square to eradicate the squared exponent, the 2 exponent. So long story short, we have to simplify this this term. So we end up with something like this, and don't forget to place a plus minus sign. Now, given that we have a plus minus sign, we can now make two equations from it. Sine x is equal to square root of 3 over 2. Then the other side, it's basically the same but with a negative. Now, of course, we have to find the arc sine of these two values. On the other side, we do the same. So, for this part, hopefully you have your calculators with you. Again, we need it. Just place the values in the calculator and the answer would be 60. So let's focus on this part first. Provided that we have a value of 60 as our first solution, it's considered a solution since it falls within 0 to 360. Now, because it's still sine, this particular rule still complies to it. We still have to follow the rule. So in order to find the second value, the second solution, don't forget the degree by the way, 180 minus x, or 180 minus 60, x is equal to 120 degrees. So that is our second value. And for 360 plus x, so 360 plus 60, it's already beyond the specification. So again, it says here that the answer should only be falling between 0 to 360. Any number beyond it or below it would be considered not a solution. If I'm not mistaken, that's those answers are what we call extraneous solutions. Hopefully I did not get that wrong. So technically this is considered wrong. So we only have two solutions there. Now let's move to this part. X is equal to the arc sine of negative square root of 3 over 2. The answer, negative 60. So negative 60 is way below the specification, so it's not considered a solution, but we could make use of it in order to find the other solutions, which are technically considered a solution, provided that they fall within the specification. Hopefully it's not really confusing. I know it seems redundant, but yeah, I do understand that. 180 minus negative 60, or in other words, 180 plus 60, x is equal to 240 degrees. So this is a solution. For the next, 360 plus negative 60, our answer is 300 degrees. Okay, so that's it for this number. By the way, I think this is important to take note of. I suppose that it is closely related with these rules. Let's move to number 3. So for sine x plus 2 is equal to 0, provided that we have to comply with the same standards. The solutions could only range from 0 to 360. For sine x is equal to negative 2, transpose to the right side, and divide both sides with the number beside sine x. So cancel. We have sine x is equal to negative 1 over 2. Find the arcsine of that value of the number at the right side. And let's see, calculator, negative 1 over 2, arcsine. X is equal to negative 30. It's not considered a solution since it's outside the specification. Therefore, we could only use it to find the other will-be solutions. So 180 minus x, or minus negative 30, x of 2 is equal to 210 degrees. The other solution, let's see, 360 plus negative 30, x is equal to 330 degrees. So that's it. We have two solutions all in all for number 3. Number 4, 2 sine raised to 2x plus 5 sine x is equal to 3. This time we could now make use of the quadratic equation method. So we solve using particular methods on quadratic equations. So we move everything, all the terms at the left side, leave a 0 on the right side, factor, or do the FOIL method. In this case, we can do the FOIL method since it is the most appropriate solution or resort that we could do here right now. So 3, negative 1. So 6 sine x minus 1 sine x, 5 sine x. Now we can make two equations out of it. So 2 sine x minus 1 is equal to 0. Sine x is equal to negative 3. Sine x is equal to 1. Sine x, x is equal to the arcsine of negative 3. On the other side, sine x is equal to 1 over 2. X is equal to the arcsine of 1 over 2. So that's how we solve it. Let's use our calculators. Arcsine of 1 over 2, x is equal to 30. So it's considered a solution. It falls between 0 to 360. Let's find the other one. It's still sine, so we have to comply with the same rules earlier to find the possible second and third solution. Just place it there. So 180 minus x, 180 minus 30, x is equal to 150. The other one, 360 plus 30 is 390. It is not considered a solution. Take note of it. Let's move to the other side. Arcsine of negative 3. In the calculator, it would state math error. So x is no solution. Alright. Let's move to number 5. Alright, so we'll be applying factoring method. since we can see that there is sine x on each term. Sine x secant x minus 3. We end up with something like this, and yeah, this is where we start parting ways. So we make two equations out of it. There you go. X is equal to arc sine of 0. Secant x is equal to 3. So just actually, yeah, let's use the calculator for this part already. Arc sine of 0 is 0. So I suppose we'll be having the same answers earlier, since it's a pretty small world, to be honest. Once your answer is 0, x is equal to 0, especially for sine, you know the rules. For sine, 180 minus x to find the solution 2, 360 plus x to find solution 3, if it were possible, provided the given specification. So again, 180 minus 0 is 180, left untouched. 360 plus 0 is still 360. So the same answers compared to number 1 earlier. For this part, I suppose that you might ask, why is it secant? Well, referring to the previous video, I suppose that we talked about trigonometric identities. There is a specific rule that states cos x or cos theta is equal to 1 over secant theta. I hope I did not get that wrong, since cos and secant are, I suppose, inverses of each other. So with that in mind, you can say here that you can transform secant into cos, provided that you'll be reciprocating the number at the right side. So given this, we could now find the arc cosine, this time, not the arc sine, arc cosine of 1 over 3. So I hope you can follow. X is equal to 70. Let's round it off to the nearest hundreds. So 70.53 degrees. So it's considered a solution. 180 minus 70.53, x is equal to oh yeah, by the way, I apologize for saying that what I recently said is wrong. When it comes to cosine, there is a different rule. Cosine, you can only have up to the maximum of 2 solutions, provided that the first solution is valid, it's considered within the specified range, and the second solution would be provided that you add 360 with the initial solution or the initial x answer value. So 360 alright, I'm sorry, it's wrong. 360 minus x. Please take note of that correction. 360 minus x, or 70.53, is basically 289.47 degrees. Alright, let's move to number 6. Now we can use the FOIL method, the reverse FOIL method, in order to factor. We end up with something like this, and we make two equations out of it. Cos x minus 2 is 0. Cos x plus 1 is equal to 0. Cos x is equal to 2. X is equal to the arc cosine of 2. cos x is equal to negative 1. X is equal to the arc cosine of negative 1. X is equal to, okay, use your calculator. X is no solution, or X is undefined. Let's try the other side. So arc cosine of negative 1 is 180 degrees. With 180 degrees, since it's cosine, we have a rule that 360 minus x would be the second solution. So 360 minus 180 is basically 180 degrees as well. So they're basically the same. So yeah, you can say that we only have one solution, since they're basically the same. When we have two solutions from a quadratic equation, and when they're the same, they're the same. For example, x is equal to 2, x is also equal to 2. Usually we have two answers for quadratic equations, correct? So we just consider one solution. Just write it that way. But I suggest just leave your solution this way so that your teacher could understand the complete version. I suppose that it would be more appreciated if you write it this way. So yeah, it's just my suggestion. Let's move on to number 7. Alright, so provided that we have cos and sine, it's going to be quite an obstacle, but what we have to do first, because we have fractions, we need to multiply both sides with the denominator. So I suppose that there's just one denominator, which makes it pretty easy, despite its difficulty. I know it's quite ironic, but yeah. Enough talk, let's continue. For a while, I'm sorry. So 2 times the quantity cos raised to 2x plus 1 over 2 sine x minus 1 over 2 is equal to 2 times 0. 2 cos raised to 2x plus sine x minus 1 is equal to 0. 2 cos x and cos x plus 1 minus 1. So yeah, that suppose... Hang on. Wrong. This is a wrong solution. We can't reverse FOIL this expression because we have two different... as you can see here, we have cos and sine. There should only be one. So I do have a suggestion. For cos raised to 2x, according to a particular trigonometric identity, cos raised to 2x is equal to 1 minus sine raised to 2x. So we can write it that way. So I suppose it's all in accord. So everything is now sine. We can already simply simplify it and factor. So negative 2 sine raised to 2x plus sine x. So 2 minus 1 is 1, so plus 1. And let's make the expression clean. Let's make this positive, this one negative, and this one also negative. So 2 sine x and sine x plus 1 negative 1. So yeah, I suppose that's how we do it. Two solutions. 2 sine x is equal to 1. Sine x is equal to negative 1. Sine x is equal to 1 over 2. X is equal to arc sine of negative 1. X is equal to the arc sine of 1 over 2. Alright, let's use our calculator. So arc sine of negative 1, I'm sorry. The arc sine of 1 over 2 is 30. For the other side, the arc sine of -1 is -90, which is not a solution. But we can use it for other real solutions. So let's box that as a final answer, one of the final answers. Since it's sine, it's sine 180 minus x, we have x is equal to 150. I hope I'm doing it right. Let me check. I need a few seconds to check my solutions so far. Let me see. Alright. Okay. So I think I see the problem now. Yeah, I see the problem. I made a mistake in this part. This is supposed to be negative. This is supposed to be positive. -2 sine x plus sine x is this answer. So from that, I can see my mistakes now. The negatives and positives are reversed. So 2 sine x is equal to -1. Sine x is equal to +1. And this one's -1/2. This one is +1. Alright, let's use the calculator. The arc sine of -1/2 is -30. For the other side, the arc sine of +1 is +90. And by the way, forgot to we're not supposed to box that answer since it's not within the specified range. So let's find the other real solutions. 180 minus x, which is -30, is 210 degrees. Don't forget the degrees. I might have forgotten that earlier. Alright, so far so good. So far, questionable. Anyways, this is a final answer. And the other x, so 360 plus x, which is -30. 360 minus +30 or plus -30. I'm sorry for the confusion. I think it won't be that confusing if you may have mastered the negatives and positives, the lesson about integers. So yeah, that's everything, I suppose. For sine here, 180 minus x is equal to 90 degrees. 360 plus x, or 360 plus 90, that's beyond the specification, so that's not part of our solutions. So again, we have the same value for x. You can write them as 1 or just leave them as is. So yeah, that's it. Let's move to number 8. 2 tan raised to 2x minus tan x minus 6 is equal to 0. This is pretty easy. Let's just apply reverse FOIL method. Write it this way, minus 3. No, minus 2 plus 3. So -4 plus 3 is -1. So -1 tan x. So yeah, that's our solution right now. Let's proceed. So we have something like this, and the other side would be tan x minus 2 is equal to 0. 2 tan x is equal to -3. tan x is equal to negative 3 over 2. Then tan x is equal to 2. X is equal to arctangent of negative 3 over 2. X is equal to the arctangent of 2. X is equal to, need your calculator right now, we end up with negative 56.3099. Anyways, let's just round it off to the nearest hundreds. So 56.31 degrees. This is not a final answer. It's not a solution. It's extraneous, if I'm not mistaken. Let's find the other. So provided that we're facing a problem that relates to tangent. So provided that sine has rules about 180 minus x and 360 plus x, while cos has 360 minus x for tangent, the rule is 180 plus x and 360 plus x. So it's similar to what we have for sine, but the difference is it's 180 plus x. So provided that we can have the maximum of 3 solutions, it's possible, but not all the time. So 180 plus x, or 180 plus negative 56.31. The answer is x is equal to 123.69 degrees. The other answer, so 360 plus negative 56.31 is, oops, wrong color. X is equal to 303.69 degrees. Alright, so let's move on to the other side. We still have a lot to solve for this. I need your calculator. You have to write this equation. So arctangent of 2 is 63.43 degrees. That's already considered a solution. It falls within the specification. So it's still tangent. 180 plus x. So yeah, 180 plus 63.43 is x is equal to 243.43 degrees. And 360 plus x. So 360 plus 63.43 is beyond the specification. Therefore, that's not considered a solution anymore. So yeah, that's everything. Let's check our answers from numbers 1 to 8 to make sure. Number 1, 0, 180, 360, no solution. Alright. Number 2, we have 60, 120, 240, 300. So we have 4 solutions. For number 3, we have 210 and 330. For number 4, no solution here. 30, 150 degrees. Right. Number 5, I think we have 5 solutions for number 5. X is 0, 180, 360, 70.53, 289.47. Number 6, no solution. 180 degrees, 180 degrees. Right. So for number 7, we have 90 degrees, 210 and 330 degrees. The last number, number 8, 123.69, 303.69, 63.43, 243.43. Right? Everything's correct. So yeah, that's how you solve trigonometric equations. Sometimes you use, or maybe several times, if not sometimes, you apply or you borrow some methods that we usually do in quadratic equations, such as reverse FOIL method, factoring, reverse distributive property, in other words. So yeah, if there are also problems whereas the application of some quadratic equation methods are not possible to be done, it's not going to solve the problem. So problems such as this one, we don't do we don't apply our methods on quadratic equations. What we do is, for instance here, you transpose the given number to the other side. These problems are usually the ones with 0. So we divide both sides with the number beside whether sine x, cos x, or tangent x. Then yeah, we still end up with something that's really close with our study of quadratic equations. We have two solutions. We make two equations out of a positive, negative, with something like this. And yeah, we do the same method. We find the arc sine, arc cosine, or arc tangent of that specific term, or integer or number, whether it's in a fraction or in a radical sign. And yeah, we apply the sine, cosine, and tangent rules. These ones, let me highlight them. So this is for sine, this is for cosine, this is for tangent. You'll always have to remember that. So yeah, that's it for this video. Thank you for watching. I hope you learned something. So yeah, thank you.